Hey guys, this is Mr. Zanoni, and today we're going to be talking about dilations, okay? Camera, just that's that should be okay. All right. So, a dilation is a transformation that enlarges or reduces a figure by a scale factor. Okay, we've talked about a scale factor before. A scale factor you multiply, always multiply by, and it can either make something bigger or smaller. Translations, reflections, and reflections don't change the size. Okay, but dilations do. Went from a big piece to a smaller piece. When the center of a dilation is the origin, you can find the coordinates of the image by multiplying each coordinate of the figure by the scale factor. We use the notation x comma y turns into k times x comma k times y to describe the dilation. K is the scale factor. Okay. A figure has vertices j 24, K 26, M 86, and N 82. Graph the figure and the image of the polygon after dilation with a scale factor of 1/2. The first step I'm going to do is I'm going to graph J, K, M, N. Then I'm going to write down, well, for our example, I'm going to graph the original first. And then I'm going to write down the rule. The dilation rule would be, we start out as normally x, y. My scale factor is 1/2, so it changes into 1/2 times x, comma 1/2 times y, because it should be half as far away as from the origin. We multiply coordinates of each vertex by 1/2, then we graph both figures on the same coordinate plane. So I graph the original, and then here's how I show my work for this, okay? So 1/2 times 2, comma 1/2 times 4. Half times 2 is 1. Half times 4 is 2. So j prime is at 1 comma 2. So over 1 up 2. Graph it right there where my finger is pointing. And I would do the same exact process for all the other points. Graph them, okay? Are these similar? Do they have the same angle measures? Yes. These are similar. Okay? They're similar with the same angle measures. Okay? But their side lengths are obviously different. This is 2, this is 1. Is 1/2 of 2? Yes. This is 6, this is 3. Is 3 half of 6? Yes. Okay? All right. Now I want you to try doing this in your notes and see what you get. Okay? A figure has vertices r, -3, 6, s, 3, 12, and t, 3, 3. Graph the figure and then image of the figure after a dilation. Okay? Obviously, this isn't on graph paper, but it should be. So I have a rough sketch of it, okay, that I made. Okay, so here's my work calculating everything, and then on a coordinate grid, I'd have to be very careful. Here's my rough sketch of everything. Okay, obviously I would do this in a coordinate grid to make it more accurate, but you get the idea. Looking at the picture there. Okay. Next example, triangle has vertices A, 1 comma -2, B, 0 comma 2, and C, -2, -1. Find the coordinates of the triangle after a dilation with a scale factor of 2. So here's how it starts out. Okay, well, we're going to... Okay. We're going to graph the triangle and its image on the coordinate plane in just a moment, but we have to use the scale factor of 2, so the dilation rule is x comma y. And now it's 2 times x, comma 2 times y, because we're making it bigger. Okay, we multiply it. So 1 comma -2, 2 times 1, comma 2 times -2 gives me 2 comma -4 for a prime. And I go through and do the same process for the other coordinates. Then I'm going to graph 2 -4 over 2 down 4. And then go and graph the other ones. Okay. The coordinates of triangle ABC after dilation with a scale factor of 2 are 2 -4, B prime is 0, 4, and C prime is -4, -2. Okay, here's another question for you to try. I want you to find the coordinates of the figure after a dilation with a scale factor of 3. So let's work this one out. So we've got x, we've got y, and we've got z. I've got negative 3, 6, 3, 0, 3, 3. Then I'm going to show my work. Okay. 3 times negative 3, comma 3 times 6. 3 times 3, 3 times 0, 3 times 3, 3 times 3. And we get our actual coordinates of x prime, y prime, and z prime. I get negative 9, 18, 9, 0, 9, 9 as my coordinates. Okay, this would be my final answer. Okay, I still have to show all this work, but this is my final answer. Okay. We also need to be able to find the scale factor. A dilation with a scale factor of k will be an enlargement if k is greater than 1 because we're making it larger. A reduction, because we're reducing it, or making between 0 and 1, it's called a reduction because we are making it smaller. Okay. The same as the original figure if k equals 1. The least useful scale factor for a dilation. Okay. If a figure has been enlarged, its scale factor will be greater than 1. If a figure has been reduced, its scale factor will be between 0 and 1. When a scale factor is 1, the size and shape of a figure do not change. To determine the exact scale factor, we use a ratio. The sides of the image of a figure being dilated are proportional to the corresponding sides of the original figure. To determine the scale factor, write a ratio comparing a side length of the image to the corresponding side length of the original figure. So if you look at this example here, we use the 0.36 and 96. We use the 0.12 and the 0.32. Okay? And we're going to use the length of the dilation over the length of the original. You're probably going to remember for finding a scale factor, it's always new over old. We have to do a little subtraction to figure out what this new length is. And same thing here. Okay? So if I count so this would be 9 minus 3 over 3 minus 1. 9 minus 3 is 6. 3 minus 1 is 2. 6 divided by 2 is 3. And that's how I know the scale factor is 3. So I'm going from this figure to this figure. Okay? And because I said it was enlarged, I know my scale factor should be bigger than 1. That's how I know it started here and became that one. All right, let's try this one. Megan wants to reduce an 8 by 10 inch photo to a 2 by 2.5 inch photo. What is the scale factor of the dilation? So this would be the new photo, and this would be the old photo. So 2 over 8, which equals 1/4. Or I could do 2.5 over 10, which equals 5 halves over 10, which equals 5 halves times 1 over 10, which still equals 1/4. Either way, I'm still going to get a scale factor of 1/4. Okay. I can always double check this by making sure that 2 over 8 equals 2.5 over 10, which equals 1/4. Okay. If I had a calculator, 2 divided by 8 is 0.25, 2.5 divided by 10 is 0.25, and 1 divided by 4 is 0.25. They all equal the same number. All right, there is a bunch of practice problems in here. I'm going to go through. I'm going to do question 1 with you and question 3 with you. Okay. So, find the vertices of each figure after a dilation given scale factor k, and then graph the image. Okay, so I know that A is -2, 1, B is 1, 2, and C is 3, -2. I'm given a scale factor of 1/2. So 1/2 times -2, 1/2 times 1, which means A prime is going to be -1, 1/2. Okay, approximately there. 1/2 times 1, 1/2 times 2, turns B prime into 1/2, 1, over half up 1. And I would use a ruler to connect these normally. Okay, and then I gotta do C, 1/2 times 3. Oh, you can barely tell it's a 1/2, I'm sorry. 1/2 times -2, which turns into C prime being 3/2, -1. So I know it's 1/2, -1's here. Okay. And those are the new coordinates of the image, and I graphed it. For number 3, we're just finding the coordinates. So I'm going to use the space down here for this. So I have M, N, O. M is the origin, 0, 0. N is 3, -3. O is 0, -6. Oh, and there's a P. So this is a quadrilateral we're dealing with, which means it has 4 sides, -3, -3. Okay, now we're going to use the scale factor of 2.5. So I need to do 2.5 times 0, 2.5 times 0, 2.5 times 3, 2.5 times -3, 2.5 times 0, 2.5 times -6. Yes, I have to do all this work out. 2.5 times -3, 2.5 times -3. So it'll be M prime, N prime, O prime, and P prime. Well, 2.5 times 0 is just 0, so still the origin. 3 times 2.5 is 7.5, and negative 7.5 for this one, since this is 2.5 times -3. 2.5 times 0 is still 0. 2.5 times -6 is -15. 2.5 times -3, we already did that, so it's -7.5, -7.5, and this would be the answer to number 3. Okay, you're on your own to finish the rest of the practice problems. Thank you for watching.